Welcome to Strong Homes, Safe Families, a podcast where we focus on building codes and mitigation, engineering, meteorology, preparedness research, and any topic that helps advance the disaster safety and resilience movement. My name is Leslie Chapman Henderson, and today I will be your host. For our episode and conversation today, we're talking to two leading researchers in wind science. From hurricanes to tornadoes, they examine how powerful winds affect buildings, including the homes where we live. They investigate building features and successes and translate them into information for standards and insights that create resilient communities. So I'd like to welcome our guests, Dr. Tanya Brown-Giammanco, Director of Disaster and Failure Studies, and Dr. Marc Levitan, Lead Research Engineer in support of the National Windstorm Impact Reduction Program, both of whom are from the National Institute of Standards and Technology, NIST. Welcome, Tanya and Marc.
Thanks for having us.
So I'd like to start with your background because it's always interesting to learn how people come to a field that is so interesting like this. So Tanya, let's start with you. What brought you to a career in wind science and research?
I was born in the middle part of the country and was around a lot of severe weather as a kid. And my dad's house was actually destroyed by a tornado when I was about 10 years old. So I really became fascinated in understanding, the weather itself, but also how we could make homes safer against tornadoes in particular, but really all kinds of wind hazards. So I did a dual degree in meteorology and then moved over into the engineering side to really bridge that gap between the two fields.
Wow, what a perfect combination to answer and fulfill your passion. So Marc?
Yes, I was also had an interest even as a child. I grew up in rural Pennsylvania outside of Philadelphia. Favorite activity in the summer was to sit on the porch, and as the thunderstorms were rolling in, and you wait for that cool gust of air. And now I understand a little bit more about why we get that. And I remember one time it started raining, and it was just raining for days, and it started flooding our basement, and all our toys are like floating around that was our playroom in the basement. It's flooding outside the yard, and the water's coming up the yard. And turns out it was Hurricane Agnes. I didn't know anything from a hurricane back then. So we had some damage, but not extreme. And then when I was at university, I was doing a dual degree in architecture and civil engineering. And when I was close to finishing up my undergrad, I got recruited into a graduate school by Professor Kishore Mehta, one of the founders of the field of wind engineering. And they were doing a lot of extensive work on lots of different aspects of wind effects on buildings and structures. So he recruited me into grad school. I got the research bug and stayed with it since.
Wow. So I just learned something, even though I've known you for a long time. I didn't know about the architecture parts. What a wonderful combination between meteorology, wind engineering, and design professional. That brings so much to the table. So we do focus here on talking to people who may not know much about these topics, but one thing that shows up in all of our surveys when we reach out every year through our annual tornado survey, as well as our ongoing conversations with people that reach out to us for counsel, is that we often find that people think in a tornado that there's nothing they can do to either be safe or to protect their home. And as we know, there's good information out there to push back on both of those. There are ways to be safe in a tornado. And now in the last 15 years, there's also ways to protect your home. So let's talk about that. There's something called the dual objective-based tornado design philosophy. And it's really evolved how we think about this. And Marc, I was wondering if you could talk a little bit about what are we talking about with that big name and this dual objective philosophy?
Sure. Well, particularly for tornadoes, it used to be thought that the only safe place was underground, right? And actually following the 1970 Lubbock tornado, one of the professors there, Professor Ernst Kiesling, had identified that, even in the worst tornadoes, oftentimes maybe the rest of the house or the building is gone, but there's a small closet or a small interior bathroom or something that was above ground, and that survived, right? And so he took that concept, worked with it over the years, ended up working with FEMA, developed that, and through there were some of these in-residence kind of small shelters that were built as these reinforced areas after the 1999 Oklahoma City tornado. They found there were some neighborhoods that were wiped out, and there was a few of these kinds of in-residence shelters that survived, and that really took off. And he became known as the father of the storm shelter industry. So for 25 years or so now, we've had a lot of work that's been done. We've developed guidance from codes. There's been industry standard. We've moved now to have a International Code Council has a national storm shelter standard for design and construction of storm shelters. And so we've had a lot of experience. And to this point, we can develop whether it's a small shelter for in residence or whether it's a big community shelter in your school or in a local public building. We have this technology to be able to design and safely to resist tornadoes. There has not been a single documented failure of a tornado safe room, that's FEMA's terminology for a state storm shelter, or a tornado storm shelter that has been designed and constructed to either the ICC or the FEMA guidance. And there's been a lot of studies of many buildings to this point have been hit even by very intense tornadoes. And so that's the first and foremost area for design of conventional buildings came out as, okay, let's focus on protecting life safety. And so for there, we designed for sort of the worst possible tornadoes that would occur. Following our work to study the Joplin tornado in 2011, we identified the need for protection and design of buildings against tornadoes, but against tornadoes that occur at the same likelihood of other windstorms. And so they're not tornadoes, while they are certainly less frequent than other types of storms, they're not as rare as we have perceived. And so we designed for earthquakes in the building code, right? We have the requirements for earthquakes. There's requirements for snowstorms. There's even requirements now in some places for tsunami, et cetera. So we do design for rare events. We don't design for those aren't designed for the worst possible. Those are designed for probabilities that meet requirements that are in our building codes and standards for certain reliability requirements. And so we worked for over a decade following our investigation of the Joplin tornado to develop new tornado load procedures, design requirements, and work to get those into the standards and the building code. And those apply to certain types of buildings, but we have new technologies now where let's design for the most common tornadoes. Most tornadoes are EF2 or less, so that means like 135 miles per hour or less. Those wind speeds are speeds that we can easily design for. Our hurricane wind speeds that we design buildings for in South Florida are 200 miles per hour, something like that. So we can design for most tornadoes, even though the tornadoes interact differently with the buildings and there's some changes from a straight line wind design. We can do that. So we're able to develop, and we have guidance out there from multiple different sources to provide information for guidance for design of many different types of buildings, including residential structures.
So the bottom line for the person who's hearing this for the first time is not only can you be physically safe in a tornado, you can protect your home in certain events up to a particular wind speed, as we're going to talk about in a little while, which is great news and completely counter to what the American public probably believes now. Whenever we do any type of prominent outreach on television, we spend a lot of time with the Weather Channel. We always get calls later from people that say, wow, I didn't know that. And how can I get one of those safer? And the good news is our big box store partners at Home Depot and others now sell them. You can go online and buy the Twister Pod for $3,800, stamp it into the floor of your garage or outside, and it is tested and certified up to that 250 mile per hour, which is just a landmark accomplishment from the experts in your field. So, Marc, you just talked about the evolution of how we tackle the challenges of tornado safety and building preservation, and you mentioned that there's a difference in wind behavior between hurricanes and tornadoes. Can you talk briefly about that and explain that for our audience and for me?
Sure. Several really important differences. The first one is that the wind speeds near the ground in hurricanes are generally horizontal, but in a tornado, as the air flows in along the ground and then it twists up, right, and then you see the core and you see those visible updrafts, those strong updrafts, they change the aerodynamics of the building because the wind is not parallel to the ground anymore, right? So that increases the uplift on the roof. We also have a difference in most other windstorms. The wind speeds are higher aloft and slower near the ground due to the friction of the wind moving over the ground. Here, as the air gets sucked in along the bottom, we have wind speeds that are actually the horizontal component of the wind speed is higher near the ground and it's lower aloft. So it's very important for design of the buildings is what is the wind speed and how does that vary over the height of the buildings. In a tornado, we also have to worry about atmospheric pressure change, right? We know just like a hurricane, you always hear that talking about a hurricane, what's the pressure in the center of the storm? And we have that, and think about the tornado as like a very, very small version of a hurricane. We have a low pressure in the center, and as the tornado is moving over the building, if there's not big openings in the building, or the doors or windows aren't open, whatever, it can take time for that low pressure to equalize out, and so that you can end up with some net extra uplift on the roof and some extra outward acting forces. So the shape and pattern of how the wind interacts with the building and the pressure fields are different for a tornado than they are for a hurricane or really any other kind of straight line winds.
But do we recommend that people open this? A call and a question, an email we get very frequently. How far should I open my windows to equalize the pressure? Do we have counsel we provide along these lines?
Yeah, no, we don't. And there was some old guidance long back, even from the Weather Service, that said open the windows to equalize the pressure. And it's a contributing factor. You're best off, and for safety, keep the windows closed. Nobody has an airtight house. We all pay our electric bill. We know how much leakage we have around the doors. There's plumbing vents. There's makeup air for the air conditioning. There's all sorts of gaps and openings in the building. So yeah, the building there is this myth that buildings explode due to tornadoes, and that's not the case. What happens is the wind gusts come along between the uplift on the roof and the pressures on the outside. It pulls the roof off. Typically, if you have a major structural failure, it'll pull the roof off. The side walls and the leeward walls have suction pressure on them just due to the nature of the flow. So those all go out, and then the windward wall blows in, and then the tornado, maybe the rubble all gets moved around. So the house doesn't really explode due to the pressure. But we found it is a contributing factor, but along with many other factors to the loads. So we have to account for that in our engineering design.
So interesting. So Tanya, Marc just talked about how the tornadoes affect and the winds affect the building. Can you walk us through how you assess or measure or evaluate how the building performed after these events occur? And are there studies you participated in where that's happened and any kind of findings?
Yeah, we along with many others, after these kinds of events, will send teams out to kind of look at how the structures performed, determine if there were material issues or connection issues or kind of deterioration issues or design issues. So there is a lot of effort by a lot of different people across the country to go out and take a look at how buildings actually performed, to try to get some baseline knowledge about places where we might be able to recommend differences in the way that we do things. I started doing these kinds of investigations back when I was a student at Texas Tech. Actually, the first tornado damage survey I ever did was the one that happened immediately after the EF scale went into place in February of 2007. So that was a very interesting experience, kind of going out and seeing how the new EF scale could be used in this way. And really, there's a lot of different things that people do. A lot of it is photographic documentation. A lot of it is really looking at the connections. Sometimes it's looking at the overall environment, what is surrounding the building. Sometimes it's linking it up with other data sets like radar-based data or other kind of observations. And I think generally speaking, the goal of most of these is to understand what happened and then understand what kind of wind speeds and forces it may have taken to cause given damage, and then identify what could be done differently. Lots of groups do this kind of thing. Marc and I are actually both involved in an effort through the American Society of Civil Engineers to develop a new standard to basically help estimate wind speeds in tornadoes and other kinds of windstorms. And it would give us the ability to do that through several different methods. The EF scale, a damage-based method being one, where you go out and evaluate the damage, compare it to how the building was constructed to start with. There's a forensic engineering method where you go through and look at kind of the forensic calculations and measurements of capacity of certain parts of the buildings. There's a radar-based method. There's a tree fall-based method. There's an in situ method where you're actually comparing observations, actual measurements from different places surrounding the storm. So really, there's a lot of different ways that you can measure these impacts. And this new standard will give us a way to do it in several different ways, which also gives us a good basis to compare and come up with even better estimates of how this is happening.
That's great news, because anything that creates consistency is eases the challenges with communications of such highly technical topics, and ensures that we're getting it right when we talk to the public. Just as a sidebar, one of the things that another piece that comes to us is the disconnect, and I haven't seen any kind of organized thing, but since I'm talking to NIST, I'd like to plant the seed with you guys to have some type, and Mark, we've talked about this before, the wind speed on the ground versus the wind speed in the air from our hurricane hunter partners. There is some confusion out there in public perception when people think they've experienced X category of a hurricane or XY, EFX speed versus what the actuality is. And I think it's a bigger problem with hurricane possibly, but I'd love to see you guys someday take that on too, so we can differentiate, because it matters, and it triggers behavior or the absence of good behavior when it comes to avoiding risk. So as you guys know, we're primarily focused on working with homeowners and renters and people concerning their residences. So I'd like to pivot and talk a little bit about homes in particular with respect to high winds. So Tanya, what part of the home in your work have you found to be the most vulnerable?
For most windstorms, you kind of have a natural progression of damage. The roof cover is one of the very first things that is damaged in most windstorms, and this has been the case for 50 years or so. There's lots and lots of events, and to some degree, it doesn't matter what kind of a windstorm. The roof cover is sort of the first thing to go. Kind of stepping up in intensity, you'll start to see siding loss. Effects on gutters, window breakage, things like that. Once you get past that is when you start to trigger some of the structural damage. But it's pretty common to see the roof cover go first. And then there's things that can happen within the structural chain that sort of trigger additional kinds and levels of damage. Mark alluded a little bit to some of the pressurization issues in one of the previous questions. And if there are big breaches in the building, such as through a window, a door, a garage door, that really starts to trigger this chain reaction of higher levels of damage.
And just as a side note for our listeners, when we say roof cover, we mean asphalt shingles, barrel tiles, metal roof, etc., whatever's on top of the underlayment over the deck, right? Okay, so you mentioned garage doors, and there's been some really high interest in that, because the garage door, unlike we provide counsel to people, we want them at the time they're getting ready to re-roof, or if they're choosing a new home with the roof, we want them to have this knowledge in mind that there are ways to protect your roof, denser nailing patterns of the deck, the roof-to-wall connections, all these things, and then, of course, the sealed roof deck, the star of the show in the last 5 years. But we also try to find those achievable things that they can zero in on, so that they're empowered to make any kind of progress toward a more resilient home, especially if it's an existing home. So the information that Mark brought to our conference a couple of years ago has really been of interest to our audience, because the garage door is perceived as more manageable than my re-roofing project, which I don't control that timeline as well as maybe a garage door, bracing it better, checking the strength of it, or even replacing. So can you talk about the garage door and the failure, and some of the insights you gained from comparisons and past studies, and what have we learned about the garage door?
Yeah, well, if you think about the garage door, for most houses, it's the single biggest opening door surface, and it's very, very big. It's often very flexible, and so when you get the wind acting on it, it's very easy to sort of flex it inward and push it off the rails, push it off the tracks, kind of cave it inwards. And one of the studies that I did, this was 10 years back or so ago, in conjunction with some colleagues at the University of Illinois. We found a really strong correlation between garage door failure and roof structure failure. And so the idea basically is once your garage door fails or kind of caves in from the forces of the wind, you allow a huge amount of air to come in and start pressurizing that cavity, the garage space itself. And once that happens, you get pressures on the wall. You get outside pushes to push the walls away and to push the roof away from this extra volume of air that rushes in. And we found in that study a really high relationship between if you lost the garage door or the garage door was damaged or caved in, you were fairly likely to lose roof structure as well. So if you go out after these kinds of events and look at performance, a lot of times if you see a garage door failure, you will often find the roof immediately above the garage is also compromised. And once that damage occurs, it can kind of take other chunks of the roof over the main structure or main house with it. So this idea that you're allowing this big chunk of air to come in and push on all parts of the house and kind of start to tear it apart, that's really problematic. We don't want to start having that kind of structural damage occur in these events. And a garage door is a place where if we could keep it in place, keep it intact, and prevent that internal pressurization that happens when the door has failed, there's a much better chance of keeping the roof together. It's not, that's not the only way that a roof can be damaged or fail, but there's a high relationship between those two things happening.
So would it surprise you to learn that that's big news to even those in the garage door manufacturing industry?
Yeah, it's not really something that a lot of people have focused on for whatever reason. But, as you sit and think, I'm an engineer, so I'm a little biased, but, you have this big thing that really traps and collects wind. If there, any listeners that are into sailing or kites or anything like that, it's a similar concept. You have this very big surface that kind of easily collects the wind and flexes, and it can flex out of plumb or out of shape. And, you get dire circumstances. So kind of logicking through how this happens, it's not hard to imagine that this could be an issue, but I do think it is an area that not a lot of people have paid attention to. So, anything that we can do to sort of raise awareness about that, because a garage door change to put in a better design is fairly easy and fairly inexpensive in the grand scheme of home ownership.
So I'm going to come back to garage doors in a minute, but I have a question for both of you. I'm going to start with you, Marc. This is like, if you can think of a big, setting aside garage doors, what do you think in your research, what kind of things have you found, Marc, that really truly surprised you at the outset? Was there any single thing or a series of things that you learned that were unexpected, either on the ground post-event or in testing or through surveys?
Well, that's a tough one. I guess we've been around the blocks on this so many times for the residential construction. Sorry, I'm not sure if I got a good answer for you on a surprise.
Well, then let's pivot the question to this. Sometimes in our survey work, it's more about validating what we already believe, and the strength of that validation can be kind of interesting. Is there anything like that? I'll switch to you, Tanya. If you can think of anything, well, Marc does, because it's always kind of, it's actually probably good news that there isn't any big giant, oh my goodness, I didn't know that you guys are seeing in the field. But is there anything that jumps out at you? Well, let me just give you an anecdote. I remember after Hurricane Charlie, I was the driver and photographer for 3 engineers. And my other job was to keep them from walking into potholes as they looked up and said, wowee, I can't believe they used staples. and all the things they were seeing were quite dramatic, a lot of unreinforced masonry, older buildings in Charlotte County. And so I was trying to keep them from, harming themselves by not paying attention. And so there were some kind of, wow, the older stuff, I can't believe it performed that way. But I guess I knew it would. Or any things like that you've seen from past investigations that were truly noteworthy?
Yeah, I mean, I think those are the kinds of things that are sort of right on target. Um, you know, as wind engineers, we've sort of known how to tackle some of these wind issues for over 100 years. There's documentation about the importance of keeping the building together by making sure the key pieces are connected. So roof to walls and walls to foundation and things like that. It's been around for 100 years. And so sort of the surprising thing is that we still don't do it widespread across the country. There's certain areas that are better than others. There's certain eras of construction that are better than others. But the fact that, from a discipline, we've known how to do this for more than 100 years and we're still seeing the same kind of failures is really challenging to face. We know what to do and it's just not happening. And how do we turn the tide to make sure that knowledge actually translates into results for people? I think that's a huge hurdle that we're still facing even today.
So I can follow up on that now. It was a good lead in. I guess maybe if we say surprising is that even with all of our knowledge that we've gained in the last 100+ years in this area, that we still see a lot of very poor design and construction, especially in the middle of the country, but even in some parts of hurricane areas as well, where we just don't connect all the parts of the building together. We talk about having a load path, right? We think about the wind starts and the action, and Tanya mentioned before, it starts kind of at the roof. And so we have this uplift on the roof. And so we've got to make sure that the shingles or your tiles, whatever, are connected down to your roof deck, right? And your roof deck has to be connected to the rafters or trusses. And the rafters or trusses have to be connected to the top of the wall. And the top of the wall needs to be connected to the studs. And studs need to be connected to the sole plate. And the sole plate needs to be connected to the foundation. We have to have that path all the way through. And so many times we don't. I've seen number of cases in the Midwest where the whole house has shifted off its foundation. There's a slider, as we refer to it, where the power cable and plumbing and electrical conduits are like the only thing that's even trying to keep the building from moving, because gravity is the only thing that's holding the building down to the foundation, right? And we know better than that, but somehow that just knowledge and skills and information has just not penetrated all the way through down into a lot of folks that are on the ground and designing and building homes in a lot of places.
So let's talk about how we tackle that. And one of the things we're very excited about is our partnership with you and bringing more awareness to things like garage doors, but even in the overarching sense, just collaborating on how to get that kind of information into the different channels from a policy standpoint on building codes or just general awareness. The meteorological community, as you know, is just a tremendous, including you, Tanya, are tremendous partners in giving voice to resilience and resilient design and codes and what to look for. So let's conjure up a little bit of a wish list. We're going to work on garage doors together, and I'm excited about that. So I'm going to start with you, Tanya, on garage doors. What's your wish list? We're coming together with some of the manufacturers and their distributors. So when that's all said and done, wave your wand and tell me what you hope we've accomplished together with these different critical stakeholders in that realm.
That is a really good question, and one that I'm super excited to answer, because I think there are some fairly easy steps that we can take. So right now, what happens is a lot of garage doors that are sold and installed on buildings are not actually wind rated at all. They don't have a label. They haven't been tested. And for communities that are using the ICC as their code basis, that really shouldn't be allowed. The ICC requires components and cladding loads to be included, and garage door is a component in cladding. And the new code also requires that the garage door be labeled. Well, if it's unrated, it's not going to be labeled. So there's already things within the code space that say that unrated garage doors shouldn't be able to be installed, but they still are. They're still being manufactured. They're still being sold. They're still being installed. So there are several kind of chains of things that could be changed to prevent this from happening. If we got to a point where the only doors that were manufactured were those that had some kind of wind rating, and there's varying scales of that. There's, the super highly rated, and then there's kind of the lower end event ratings. But if everything at a minimum had a rating, I think that would be a really positive step forward. Obviously, we need to make sure that those rated doors are installed correctly. We want to make sure that they're labeled correctly. But I do think just getting that first simple step of let's not manufacture and sell doors that aren't rated would make a huge difference. And, garage doors aren't something that a lot of people think about. People just assume that, my garage door is fine, there's nothing special about them. But, the truth of the matter is that those that are rated usually have some kind of stiffening added to them. They often have better hardware that attaches them to the walls. And really all we're trying to do is prevent that flexing and that caving in that allows that huge gust of air, that huge burst of air to come in. And we can do it by focusing on only having doors that are rated. Of course, the highest rating is best, but that's not necessary everywhere. Let's just get something that's rated.
That's a perfect prescription for the road ahead for us as we come together with those individuals, because I think as industries go, there are always leaders, and then hopefully, typically too, even with tornado safe rooms, that's how it started, and then everyone follows. So that's perfect outlay for that, and great information for everyone listening. Marc, I'm going to give you a magic wand and reference the work you've been doing on Wind Standard and IBC, and waving your wand to the future. Where do you want to see that work go with respect to homes and the use of that great information?
Sure. I think our most important tool, and Flash is at the forefront of trying to move some of this information out to homeowners, is the fact that we just have to have a building code and a residential code, and we need to get those adopted and enforced across the country. There's so many communities that don't adopt, or maybe they've got one that's 20 or 30 years old, or it's not enforced. And just so folks understand, we have model codes, International Building Code, International Residential Code, for example, and those are developed through a consensus process where we have all the relevant parties that can participate. This is our best ideas on how to design and build these kind of structures. And then it's up to states and localities, and every state is a little bit different, right? Some states, like Florida, there's a state mandated building code. Other states are more home rule, and it's up to individual counties or cities or other authorities having jurisdiction. And there may be a mixture of certain kinds of construction is regulated, perhaps commercial, and residential are treated differently. But at the end of the day, whatever the appropriate authority having jurisdiction, whether it be a city, a county, a state, those folks really need to work to adopt the latest, most hazard-resistant codes, and then to work to train their building inspectors to enforce those requirements. And as a homeowner, and I know sometimes people have a negative idea of it's more regulation as building, the building inspector should be your best friend, right? If you're buying a new house or getting a major addition and you have the building inspector come out, the building inspector is the one that's going to help make sure that the work is done right and that you're going to get a quality and a safe product, right? You should be excited and happy when that building inspector is going to come out and work on your property. It's not someone that, just regulate. No, that there's your tax dollars and your fees are hard at work, making sure that you get something safe, right? In the auto industry, right, we've got all this sort of safety requirements, and people work through all this testing and all that kind of stuff to make sure, and government regulations to make sure we've got the airbags and they're working, all that kind of stuff. Where do we have that for buildings, right? Who's responsible? Who's make sure that building that I'm going to buy is safe? I mean, maybe the fire marshal comes out and inspects to make sure that the fire alarms are installed correctly, right? The smoke detectors. But otherwise, beyond that, in some communities, that may be all that happens, or maybe not even that much. So we want to really encourage our population to go ahead, and if your community doesn't adopt and enforce the latest building code, go to your city council meeting. Say, hey, I want to make sure when I build a new house, or my kids are build a new house, or buying something, or doing a major repair, or something like that, that we have those skills, we have those capabilities, we have those requirements in our community to make sure that we have modern and safe design and construction practices, and that things get built correctly.
That's a great reminder too, because we're not there when the home is built most of the time, right? We're buying an existing home. And I do want to mention a tool, and we're going to put a lot of your information in our show notes for the listeners too, with the time codes for different aspects of our conversation. Flash has put out a new tool that is a building code tool, wherein you can go to stronghomescale.org or inspectorprotect.org and put in your address. And what it's going to do for you is give you a comparison between the assumption made in our data set that includes Zillow, Verisk, and others of what building code was used when your home was built, say 1980, and what is in the International Residential Code today, plus safe rooms, because we don't consider a home tornado resilient without a safe room. That's just how we are. And then it's going to show you the features, because it is critical that we overcome the lack of understanding of those pieces, as you talked about, Tanya, connections and the garage door, and having them applied, as you pointed out, Mark, and implemented. I mean, they're no good. The science, we always talk about our role is not science, engineering, research. That's what's so wonderful about having all of you. Our job is to take that science to the street, through the front door, to the kitchen table, so that people, when they're buying a house, are saying, what are the features that I have? So if they go to the scale, they can see the features, and they may recognize some that they already have. They can click on them and play back and forth. It's a very simple type of exercise to help people get started to understand. And the kind of information that you guys have produced has really informed to that and made things like what we do possible, because you're the cornerstone of resilience and knowing how to build. When I hear that we've known for 100 years, I think of, yes, we do have to keep working on implementation. Before we wrap up, is there anything that we haven't talked about yet that you want to share with our listeners, or any type of resources you want to ensure that we include in our show notes?
I'll just say one of the best opportunities to work on an existing home and improve the wind resistance is particularly when you are doing a roof renovation or a roof repair, right? A lot of times if you have an asphalt shingle roof is our most common roofing type for residential construction. And those wear out after, depending, 15, 20, 25 years, or maybe you have a hailstorm and you need to replace the roof. And that's your opportunity right there, is when you're stripping that roof off, right? You can go back and see, and your roofer can go back and look, and they'll typically look to see if some of the oriented strand board or the plywood that's your roof decking is damaged. But we want to do that, but we want to make sure that it's connected well. They can see that, and to go back and make sure to re-nail with ring shank nails or screw down the deck, because in the old days, and we used to use sometimes staples, we used to use smooth shank nails. They have very little resistance to uplift, and so those sheets are easier to pull out. Or sometimes the nails are overdriven and they damage the wood, and the heads are too deep. Or you get shiners, right? You can go up in the attic and you see, oh wait, there's a whole lot of nails, but they all missed the rafter, right? All those sorts of things. So there's an opportunity for you to repair any damaged sheets, re-nail or reconnect those roof sheathing down, and then when you go back and put the roof on, to use a secondary moisture barrier to where you can have a special peel and seal over the joints or other barrier, to make sure that even if you do have some shingle damage in the future, that the water doesn't get down through those joints in the plywood. So you're doing just things that are pretty easy and low cost, but you can make your roof much stronger for the next time that a storm happens.
And if they reach out to IBHS or other partners, they can get a designation of a fortified roof as well, which will help with their insurance. Tanya.
Yeah, that's absolutely true. Well, kind of following on Mark's footsteps, get a good garage door is sort of my big message here. That's a 1-day project to replace a garage door. So if you're looking for ways to make your home safer and more resilient, or your old garage door is worn out, or you got a teenager that backed into it, or whatever the case is, use that as an opportunity to pick one that is wind rated and has the bracing and the hardware that's enhanced to help make that installation safe. And then, Mark said this a few minutes ago, but I'll just echo it again. Our community members do have a say in this. There are many communities that don't adopt a building code, or don't enforce it, or don't adopt the latest one, or, take provisions out of it. And, as a community member, you do have a voice in those. So whether it's at your county level, your city level, or even your state level, let your representatives know that building safety matters to you. You want to live and work and go to school and shop and, do all those kinds of things in buildings that are going to keep you safe while you're in them. So if that's something that matters to you, make sure your representatives know about it.
That's great advice. Tanya and Mark, I really want to thank you for joining us today. but also for your dedication to wind science and to the research that you do and your service to our nation. We appreciate you sharing the information with us and our partners, and we also appreciate the opportunity to raise awareness of the insights that you've raised. And so we're all going to go out from here thinking about our roof and our garage doors. I want to also thank all of our listeners for listening to this episode of Strong Home Safe Families. Don't forget, you can email us with your feedback to info@flash.org, or you can call us toll free at 877-221-SAFE. That's 877-221-7233. And of course, please don't forget to subscribe, rate, share, and provide us a review on iTunes. So until next time, stay safe.